Hello everyone, thanks for joining me yet again. We're going to go ahead and dedicate this flip lecture to Thomas Crapper because that is the theme of today. Contrary to popular belief, Thomas Crapper didn't invent the toilet. He actually just popularized it. And so anyways, that's what we're all about today. Our objective is that human waste obviously poses serious health threats, both for wildlife and for people. We got to deal with it. And we can deal with it in both a physical way and a biological way before it is discharged. And just so you know, before we get going, most of these slides are from the South Bayside Authority, which is the place we're going to visit next week. And so we'll get up close and personal with it there. So here's the Cornell outline. Our essential questions are, we're going to start with this question: how do we manage pollution? Just an overview with that. And then we're going to get into the sewage. And there's three stages you can do to treat it. There's a primary, secondary, and then sometimes tertiary as well, although we don't do that here in Redwood City, the Redwood City area. So just overview, when we think about pollution management, we should be thinking about two things. We've got prevention or control. And so prevention is just, stopping or reducing the pollution at the source. So for example, walking instead of driving, or using a reusable bag instead of a disposable bag at the grocery store, using unleaded gas instead of leaded gas. That was a way to take the lead out. We prevented that. Or just driving better, more fuel efficient cars. We need to, we can still drive, but we're burning less fuel. That's prevention. Control is recognizing that wherever there are people, we're going to have waste, and we got to figure out how to deal with it. And so, how do we contain it? How do we minimize the impact? For example, a landfill. We've got all this garbage. We're going to keep it in one spot. We're not going to let it pollute the groundwater. And what we'll find is wastewater treatment does both of these things. Point source pollution versus non-point source pollution, just two ways to look at what the source is. And you want to know those two vocabulary words, and it's straightforward enough, I think. Point source pollution, it means we can point at it. You can point your finger at it. Here's our factory, and it's got emissions coming out the top. Easily identified. Non-point source gets a little trickier, where we've got really diffuse sources of pollution. They're moving targets, they're small, but it all adds up, right? And so a car leaking oil. You see the oil on the street, there's no way to trace that back to the car. Or you got the algae bloom, we've got too much fertilizer, we don't know whose lawn it's coming from. And so as you can imagine, that's a lot harder to deal with. With this, we can just go, we can put a scrubber on that smokestack and reduce sulfur dioxide emissions, and we can control it or prevent it that way, but it's harder with the non-point source. So here we go. You're going to want to jot these down, maybe hit pause. We're going to hit the health risks with fecal contaminated water, and then we're going to do primary, secondary, and tertiary treatment. And I'll show you some slides on those starting now. And so I don't know if for people that have traveled outside the United States and like developing countries, maybe you've seen something like this. Here in the United States, we take flushing toilets for granted until they don't flush anymore. And you can imagine how much of a problem that would cause. Lots of places in the world still have this kind of setup where you just got open sewage, canals, yuck. You can just imagine the stench and the vermin and the disease that comes along with it. So we're very blessed here in the developed world to not have to deal with that. We've got issues, though, and sometimes our wastewater treatment centers can fail us. Here's a couple shots from after Hurricane Katrina, which wiped out the wastewater treatment centers in New Orleans. And so these guys down here are going through raw sewage. And when you've got contaminated water, you've got problems that we're not so familiar with here in the first world. You've got dysentery. I guess we're familiar with diarrhea, hopefully not too familiar, but other places, diarrhea can kill you. All these waterborne diseases, you want to jot this down in your Cornell notes: typhoid, cholera, polio. You can get epidemics, and so we don't really hear about those too much here, but looking at other places, that they're killers, and they could easily be avoided. So why do we need to treat the water? We've got public health issues. We want to be able to go use the water. We want to not be afraid of it. We've got protection of wildlife and ecosystems, and then especially this idea that water can be recycled. we are scarce on water. We've got a growing population and growing demands for water, and we need to be smart about how we use it. It's like, should we be using hetchy drinking water to water a golf course or a park or landscaping? And so maybe there's some ways we can reroute that water. And so the purple pipes are kind of the symbol around here for recycled water. So how many wastewater treatment centers do we have here in the Bay Area? 49. There's the number. Why so many? Well, it's because we've got a lot of people. And they're living all over the place. And so 49 different treatment centers to service all. Everybody's using water. They're flushing it. It's going down the kitchen sink, the showers, the drains. And so we got to deal with it. 700 million gallons a day. That's a lot of water. You can imagine what it would be like if we didn't have a system to navigate that. And so what is in our neck of the woods, we've got two big ones. The biggest one is down in San Jose. We won't be seeing that one. It treats 167 million gallons a day. Ours treats a mere 29 million gallons a day, which is a lot. How much is it? It's like 29 Olympic swimming pools. Or here's a little for you basketball players out there, 150,000 basketballs would be 1,000,000 gallons. So we've got 150,000 times 29 million a day worth of water coming in. It's a lot. And so here's where all 49 of those treatment centers are. Notice that they're all on the water along the bay. If you've got millions of gallons of water coming in, you got to have a place for that to go. And you wouldn't build one of these things on the top of a mountain, right? You're not going to pump it uphill and then have it spill on the other side. So we're right on the water. These ones up here are on creeks and rivers, right? There's got to be a place for that water to go. And so they get very high tech about when that water's coming in. They got to be ready for it. And so this is kind of interesting. You can see like right here, this is time going down here. Here's when we all go to bed, sleeping, not using too much water, and then bam, there goes the alarm. We wake up, go to the bathroom, take a shower, brush your teeth, go to the bathroom, and the water peaks. Then we all go to work and school, comes down, and then we all get home and start using more water again. And so they're ready for it every step of the way. They've got to be. So how do they do it? Here's like an overview. We've got our primary part here, and then this whole thing's secondary. And so we're gonna get into that right now. So here's what's coming in. It's called influent. That's a vocab word you want to have under your belt. Influent is, and you can see it's obviously dirty. You can imagine what's in it. Effluent is what's going out. Effluent out, influent in. And that looks a lot cleaner, but it's not 100% clean. You can't drink it. It's about 90% clean, and to get it 100% clean, it takes a lot more energy and it gets more expensive. We'll probably be doing that in the not too distant future. And here's the recycled water going in the purple pipes, even cleaner, but not 100% clean yet. Here's what happens. Influent comes in through these big pipes. Comes in fast, and then they stop that water. So here's primary treatment. Primary treatment is essentially they're just using gravity or just physical properties of the waste to try and separate it. So they call it sedimentation. The sediments will settle out. You stop that water, just let everything kind of settle. And then the things that are like less dense and insoluble in water, like oil and stuff like that, float to the top. They skim that off. They get all that sediment out, separated it, and then they go on to the next stage, which is secondary treatment. Lots of places in the world that flush toilets only do this, and we actually only used to do this until we got a little bit more high tech. This is where it gets cool with the neck. So this is secondary treatment now. The water, now it's just liquid water, but it's got all this organic matter that's still in it, and it needs to be treated. And so what they do is they do all these steps that basically get into allowing what they call activated sludge, which is really a bunch of different types of creatures. Here they're calling it, it's bacteria. It's also like little protozoas, and we'll see some of it. There's like a whole universe going on in just a drop of it. And so these creatures will do the work for us. And so what we do is we set up the best possible conditions for these creatures to do the work. We pump it full of oxygen, get the water at just the right temperature, get it moving, and let these creatures do their thing. And they digest the organic waste, and they basically, take care of it for us. It's pretty cool. So we get it's a biological system. And then we try and we run it through a couple more filters and try and get it as clear as possible. Advanced treatment. We'll see this and filtered one more time. And then the next step is we gotta basically, we can't discharge all those living creatures, and so they basically hit it with bleach or sodium hypochlorite bleach for the most part. They hit it with that, kill everything, sterilize the water, but then they can't pump that, they can't discharge that. So the next step is they got to dechlorinate it, and they got to get all that chlorine out of there so they don't put that out into the Bay Area. So then they discharge it. It goes out to the Bay. It's much cleaner. But one thing to recognize is you got 49 of these places in the Bay Area doing that, and they're pumping fresh water into a saltwater system. And so even if it's clean, that's an issue in and of itself. But there may be ways around it. We need to start thinking outside of the box. But this is our system we have for now. The tertiary system would be if we could take that effluent, instead of just dumping it straight into the bay, run it through a wetlands, and then you let the plants kind of like suck up the because there's like heavy metals, there's stuff in that water that we don't screw that those creatures aren't going to take out. Medicines that get flushed down the toilet and things like that. And so if you run it through plants like wetlands, like they do in Pacifica, not too far away from here, state-of-the-art wastewater treatment center over there. That's the next level. We don't do that yet here, but we could. So just a quick word about recycling water. Why would we do it? It just basically conserves water. If you think about it, why, like I mentioned earlier, why are we using drinking water for a lot of these purposes? We pump this water all the way from hetchy, pristine water, and then flush it down our toilets. That doesn't really make a whole lot of sense. Or water a golf course, or use it to cool a power plant. And so we've got to get smarter. And so recycled water is part of it, but it takes money to set up all those purple pipes. And we'll see those purple pipes. We'll learn more about it when we're there. It's a great concept, but it ain't deep. All right, keep going. And so just to kind of like lay it out here, here's what we just talked about. Go backwards. There it is. So one thing to recognize is that we've got we have that solid stuff coming out, and that's waste, that solid sedimentation. And so what they'll do is they'll take it over to the landfill and use it to cap the garbage rather than using soil. So kind of interesting. And then there's a little solid left over. And what are they going to do with that? They've got the anaerobic bacteria going on, and so they produce methane gas, and they actually run a lot of their plant off that methane gas. Kind of cool. We'll learn more about that as well. So a couple last words here. One distinction to make is anything that's going on the street, going down the storm drains, does not go through this system. Unlike in San Francisco where it does. It's a combined system up there. But down here, anything going down the storm drains is not treated. So only rain down the drain. We'll be testing our stormwater runoff later next week to find out what's in that. By Nemo. We're going to speed up here. So just a couple things to wrap it up with, and they'll speak more to this when we're there. We got to just to point out some career opportunities. There's all kinds of things that are related to this, and it's not all out there shoveling poo. They've got a high-tech lab. We are getting closer, and some people are out there shoveling poo, and they get paid a lot of money. But there's all different angles on this whole industry. Wherever there's people, there's going to be waste. And so just to think about that as a possibility. And I can tell you the water situation in California, we've got some things we've got to be thinking about. So keep your mind open to possible careers in this field. Very important. Okay, we're going to go ahead and sign out. And thanks so much for hanging in there with me. I hope that was interesting to you, and think about it the next time you flush the toilet. All right, take care.